maturity model. Okay, so we tried to prepare some model to evaluate the situation or the position of internal logistics in companies, but we were focusing mainly on technologies or concepts of Industry 4.0. As I said, we tried to identify some potentials of the internal logistics, and also we, as I will show you in my presentation, we try to present a table which incorporates a detailed overview of all models, but also we tried to design readiness model for evaluation of internal logistic processes in several areas. So, first of all, I think you all know what Industry 4.0 means. If you are talking about the fourth industrial revolution, that the first industrial revolution was, of course, by steam machine. The second revolution were some manufacturing. The third revolution is incorporating some computers, and of course, Industry 4.0 takes some elements from the robots parts, take some element for the computer parts, take some element from people, and this this all is like incorporated by the term Industry 4.0. Of course, if you are talking about factories, we are dealing with the name which goes by smart factory. The smart factory is using elements of Industry 4.0, is using elements of modern technologies, and all these elements are used here, but we are focusing solely on the field of internal logistics, or let's say Logistic 4.0 as we named it. If you are talking about this internal logistics or intralogistics or micrologistics, there are several names for this. We are talking about some planning, some implementation, some control, some material flow, storage of materials, finished or semi-finished products, production processes, and of course, we are not talking intra-company, but of course, we are dealing with some environment. If we want to say what are the main activities of intralogistics, they are packaging, storage, deliveries, manipulation, and material identification. If we want to talk about Logistic 4.0, smart logistic, we can say that this is the definition. We are talking about some integration of all these elements. You can see automatization, digitization, robotics, Industry 4.0, internal logistic activities. But if we are talking really about logistics, the most deciding factor here is our technologies. You can see in this table there are various technologies which are already used in factories and which help us to implement logistics with Industry 4.0. You can see there are some classic, let's say classic technologies of Industry 4.0 like big data, smart. Of course, we are talking about logistics, RFID, Internet of Things, Internet of Services, robots, and of course, autonomous AG vehicles with some GPS. I think my colleague a couple of minutes ago was mentioning drones. So yes, drones are also incorporated with Logistic 4.0. You can see here also, if we are talking about some people implemented into smart logistics, wearable things, voice detected headsets, glasses, activity trackers, and so on and so on. So these are the technologies mentioned here. Now we will try to talk about something about our proposed model. We're really trying to find some model which would fit the use of intralogistics into the company, and we analyzed, let's say, 10 models. From these 10 models, we were told that these 3 models are the best that would fit us: CMM model, CMME model, and SPICE model. Of course, we tried to propose a comparative Industry 4.0 readiness measurement on this micro level, and the main attributes of these evaluated models were name, origin, dimensions, and areas. This is the most important for us, the potential of the logistics dimension. Because from these models, we are solely interested on logistics, also readiness assessment, and model intents. It means the model is descriptive, comparative, or prescriptive. On this slide, you can see all the models, which are, of course, described in the article itself. And you see Impulse, SIMI model from PwC industry. This is a maturity model for assessing Industry 4 readiness. DREAMY, Industry 4 readiness assessment for development of an assessment model for Industry 4.0. WMG model, Singapore Smart Industry Readiness toward a smart manufacturing maturity model, and of course, Logistics 4.0 maturity model. These were the main principal models that we try to somehow analyze, and we try to find Industry 4, we try to find Logistics 4.0 factor here. As I said, we were analyzing 10 models. Only 6 models were dealing with logistics, which is a key factor for us. And from these 6 models, we tried to pick these 3. Maturity model for assessing digital readiness with 5 levels, Singapore Smart Reality in the Singapore Smart Industry Readiness Index with 6 levels, and Logistics 4.0 maturity model with 5 levels. Now we are trying to propose a model from these above mentioned 3 models, and the main parameters were set by analysis, and we divided 3 main parameters. That means areas for evaluation of internal logistic processes, focusing on technology, information, and people, logistic process of evaluation levels, and dimensions of internal logistics. We determined these, let's say, 5 levels with 0 level, and we are starting on level 0 when processes are not defined. On level 1, there exists some certified process management. On level 2, digitized data acquisition. On level 3, some parts of the processes are automated. On level 4, processes are automated with limited control. And on level 5, processes are fully automated. People only control if everything is okay and do not interfere much. As I already mentioned, for areas of assessment, there are 3 areas: technology, human, and information. And the new model is shown on the table on slides, which I will present next. And as I already said, there are 6 levels. There are 3 areas of evaluation: technology, human, and security. And here is the model itself. So you can see there are 1, 2, 3, 4, 5, 6 levels, and each level is divided into 3 areas of technology, information support, and people. You can see on the level 0, there is logistic processes without the use of information technology. And you can see from 0 to, let's say, 5, these technologies are getting more and more, let's say, sophisticated. We have on level 1 printing documentation. On level 2, some data collection is being deployed. On level 3, logistics is connected to information systems. On level 4, logistics is integrated into whole the environment. you are seeing we have some robotic devices here, and if they fail, they receive their instructions. And this is level 5, is the most advanced level on our model, which represents that logistic technologies are being fully automated. That means we are using complex systems, we are using AI, we are using algorithms, and of course, full digitalization. If I'm talking about information support, on level 0, we are using only some paper, or we are not using any information support at all. From level 1 to 5, you see also the support is getting more and more complicated. Information systems are implemented, data storages are implemented, software is special software is used. Now on these high levels, also hardware, which are robots, sensors, and so on and so on. And on the most advanced level, you see specialized hardware with artificial intelligence or advanced algorithms. The last characteristic which we chose from our model are people. And of course, you see these are on the level 0, there are people not so well educated in these processes. So if anything happens, they try to fix it. There is no information systems, and we are advancing to higher levels. You see, information systems are being implemented. People are trained to work with them. They are gaining some skills. And on the last level, the employee only controls logistic processes, but does not interfere with them. That means from the classic logistics workers with some hammers and tools, we are moving to IT specialists, to programmers and data analysts. The last row in this table, last column in this table is example of used elements. And you see, we try to orient this on logistics. So you see on level 0, we are paper forms, manual handling equipment. On level 1, we are moving to forklifts, conveyors. Level 2, you see barcode scanners, QR scanners, warehouse management systems. If we are moving toward higher levels, terminals connected to information systems are being used, RFID, automated handling equipment, automated storage systems, and on the last level, we are using fully automated warehouse with very, very, very low interference of people here. So we tried to somehow analyze the information of internal logistic processes. We tried to improve them. That's why we tried to propose some model of Logistics 4.0 in coherence with Industry 4.0 concept. This model is, let's say, just a beginning. In order, if you want to implement these technologies, the companies should know in which of these 6 levels they actually are at and what they do want to improve. Of course, you see that the detailed evaluation will consist of dividing the entire area of logistics into subdimensions. That's why we were talking about here you can see the example of elements used. Each of these subdimensions should, let's say, use some things from the model. Of course, this is only the beginning of our work, and we will try to improve this model in the future. You can see that this is very important because the levels of evaluation of logistic processes for given dimensions and their areas are divided into these 2 parts: dimensions and their knowledge, level definition of description. Same goes with dimension of area, parameters with a given level, relations between levels. That means definition of these 2 parameters and link between them. And of course, the last point is assessment tool and level assessment corresponding with Industry 4.0. You can see that we were made some questionnaires, some checklists, documentation, observations, and of course, it's very important to determine where the Industry 4.0 at a given company is, what are they using, and of course, what kind of technologies are used there. So this was a brief description of our article. I hope you like it, and if you have any questions, don't hesitate to ask now.
Thank you, Peter, for a wonderful presentation. Do we have any questions? It's really nice that your research is actually for the century. I mean, IoT 4.0. It's really nice to see that research out here. So, well, do we have any questions? Workman, would you like to ask any? You can unmute yourself.
I didn't have a question. I just enjoyed the presentation.
Yes.
Yes.
Yes, oh, thank you very much. Thank you very much. I enjoyed your too, by the way.
Thank you.
Thank you, Peter. So what about this smart city model you were talking about? Can you just elaborate on it? Like,
yes. Well, it's not about smart city. I was talking about smart factory, which is basically there are some common elements with smart cities and smart factories, because we are trying to make the factory with the least minimal approach of, or least minimal interaction of humans there. We are trying to build the production line fully controlled by robots, fully controlled by sensors, fully controlled, for example, by drones, with really minimal activity of humans there.
Mm-hmm. Yes. But like, there is a normal question saying that IoT 4.0 will replace people and job scarcity will be there. So how will you tackle those issues?
I don't think it will replace people at all, but yes, okay, it will replace some let's say basic maintenance workers and stuff. But
yes,
as I'm mentioning it there in the people column, you see that we are people's on level 1.
My question is the same thing. In the people column, you have mentioned wonderful. I really liked that people column out here. My question is like, like a densely populated and middle, growing developing countries like and all. We have a lot of labor works and all those things. So, and in many countries also, we know that like maintenance department and engineering department has many low level staff. So
Yes.
this particular thing, if they only if we focus on like IoT, if it is doing everything, machines are making itself clean with the help of robot and all those things, right? The man would be replaced with respect to machine. So job opportunities may.
Well, yes. Some of the basic functions will be replaced, but as I'm mentioning here, you will always need people for, let's say, for the Industry 4.0 factory, because you need IT specialists, you need programmers and data analysts.
Yes, correct.
So there, I don't think there is like 100% factory without any interference of people.
Yes.
The people will always be needed. Just, let's say, their job functions will be totally different from now.
Yes, wonderful. Nice to know that. Very good presentation. Thank you for sharing your presentation. We'll be connected. Lot of things started to learn from you. Thank you, Peter, for your wonderful presentation.
Thank you very much. Thank you very much. Goodbye.
Goodbye. Yeah. So, do we? Okay.